comparing scaling velocity of IaaS, CaaS, and PaaS. Your host for this session is Richard Spencer. In this video, I want to talk a little bit about infrastructure as a service versus platform as a service versus containers as a service. These are three types of cloud computing service models that you can encounter in Google Cloud. So we'll talk a little bit about each one. Then we'll look at the services that coincide with these models in Google Cloud. So let's start with infrastructure as a service. Infrastructure as a service provides end users with a cloud-based alternative to on-premise physical infrastructure, so you don't have to deal with on-premise physical servers anymore. You don't even have to deal with the underlying hardware, the heating, the cooling, right? All that goes out the window now. You're using Google's infrastructure as a service, and it's very scalable. You can scale up when you need the extra capacity. You can easily scale down when you don't. And that's not something that you can do in an on-premise physical iteration of a data center, right? You get pay-as-you-go storage, pay-as-you-go networking, pay-as-you-go virtualization. They're highly flexible and highly scalable. So what does Google offer as infrastructure as a service? And one of these are the Google Compute Engine. So if we come up and we type in Compute Engine, we can go to the Compute Engine product page. This is a cloud-based pay-as-you-go infrastructure as a service. I can create virtual machines here. I can create scaling groups. I can create dedicated instances. I can use whatever machine type I want, whatever image I want. So the scalability of this compared to an on-premise iteration is leaps and bounds, much more scalable horizontally and vertically. You also have platform as a service. So platform as a service, or PaaS, provides your developers with a framework, provides them with software and the tools they need to build their applications and the software. So it's a bit of a scaled down version of infrastructure as a service because it gives developers a place to write their code and deploy their applications, but they don't have to worry about the servers or the storage or the networking, right? So it's very scalable. Customers can choose from various tiers of computing resources. As you grow bigger, you can scale up and use bigger compute resources, right? Or configure your application to scale horizontally. And it's great for developers who are building software, applications, or building workflows, and they don't want to deal with the underlying hardware, all right? It's very easy to integrate. They have great data security. So what does Google offer you as a platform as a service? So Google offers platform as a service through Google App Engine, and that's one of their platform as a services. So if we come up to the search bar and type, we're in it now, we'll see a product page. Let's go ahead and click it, and then we're brought into Google App Engine. And this is a platform as a service. This allows us to deploy all our applications and not have to worry about the underlying hardware and the software. Google BigQuery is also a fully managed serverless data warehouse. It's considered a platform as a service offering. Google Kubernetes Engine and Apigee API management also allows for you to design, secure, and scale your APIs. These are some advantages of platform as a service and some examples of platform as a service. That said, Google App Engine is the leading Google platform as a service offering. And finally, container as a service. So Google Kubernetes Engine. If we type Kubernetes, you'll see Kubernetes Engine. You can go ahead and select that product page and you'll see. Now that we're brought into Kubernetes, we can create clusters and workloads and so on. So Kubernetes is a managed Kubernetes service. You can host your highly available and scalable container workloads. You can deploy a multi-zonal and regional, so it's very scalable. You can choose graphic-intensive machine types. You can choose machine types for machine learning, and you can augment GKE through specialized hardware accelerators like a GPU or a SATA TPU. You also have Cloud Run, so if we come up in GCP and we type in Cloud Run, we can click the Cloud Run page. Cloud Run allows you to run your containerized applications without managing the underlying infrastructure. You can deploy it into an Anthos GKE cluster or an on-premises workload, but it's a well-integrated service, and it integrates well with Cloud Code, Cloud Logging, Cloud Monitoring, and so on. This would be also considered a container as a service. So I hope this video showed you the differences between infrastructure as a service versus platform as a service versus container as a service, and also showed you some of the options in Google Cloud Platform for each of these cloud delivery models. In this video, you will learn how to describe the geographic distribution of Google Cloud services. geographic distribution of Google Cloud services. Your host for this session is Richard Spencer. Now let's discuss the geographic distribution of Google Cloud resources and services. So GCP is built on the concept of geography and regions. Google Cloud has infrastructure and data centers across multiple regions all over the globe. North America, Europe, Asia, Australia, South America. And within these regions, you have zones. And zones are different, isolated data centers within a region. So you can choose where you want to locate your applications. It can be in South America, North America. It could be in US East, could be in US West. And you can implement high availability by using multiple zones within a region. So regions and zones, we just talked about it. Let's go in a little bit deeper, starting with regions. So these are independent geographical areas, and regions consist of zones. So one hypothetical way to look at this is by using a couple of use cases. Our first use case would be our application. Our application needs high availability. All of our customers are located in the US, and we're using a region, US East. But we deploy our application over a couple different zones in US East. One, US East 2, maybe even US East 3. So we get that high availability. So if one zone or one data center were to experience a catastrophic fault, we still have high availability because it's in the other two zones within our region. We can also take it a step further and think of regions as a disaster recovery mode. So we deploy in US East, but we also have a failover in data region. So if something catastrophic again were to happen to the entire US East region, we can fail over to US West or Europe somewhere. The choice is completely yours, right? But regions and zones provide disaster recovery with high availability, and that in turn provides low latency, your application being much closer to your users and so on. There's so many advantages of this architectural setup. But with global architecture being divided up into zones and regions, you're going to run into resources that are only available in each specific area. So you have global resources, you have regional resources, and you have zonal resources. So let's take a look at global resources. These are accessible by any resource in any zone within the same project. Global resources are addresses. So any global, static, external, and external is a keyword here. IP that you reserve for your project is a global resource. Images, so disk images, VM instance images. If they're in the same project as the image, they're global resource. Snapshots, persistent disk snapshots are available to all disks within the same project. Instance templates are available to anyone in the same project. It's a global resource. However, you can specify some zonal resources in an instance template, and as a result, if you're not in the zone that zonal resource makes you be in, then you're not going to be able to launch that instance. So it's a little caveat you have to keep an eye on. And cloud interconnects. This is a highly available connection from on-premise to Google's network. And cloud interconnects. This is a global resource. Some other global resources. Cloud interconnect locations. This is a physical connection point for cloud interconnect near your network. So there's one cloud interconnect location for every available co-location facility. And these are read-only global resources that you can take advantage of. Your virtual private cloud, global resource, your firewalls, and your routes. These are global resources. You don't have to recreate these for every region or zone that you may be in global operations. So global operations are per zone resource, per region resource, and data. So if you're performing an operation on a global resource, that's considered a global operation. So inserting an image is a global operation because images are a global resource. Regional resources. These are available by any resources within the same region. These can be any regional static external IP address. Remember, we had global static IP addresses as well, but you can have regional static external IP addresses. Cloud interconnect attachments. So an interconnect attachment is a VLAN allocation in a cloud interconnect. This is a regional resource, right? It's not a global resource. And subnets. Subnets are regional as well. So subnets segment your network IP space, and they control which prefix and instance internal IP address is allocated. So it could be 192.168.1.0, 192.168.2.0, and these are all subnets. And these are all regional resources. More regional resources are regional managed instance groups. So if you have a collection of identical instances that span multiple zones, Regional managed instance groups let you spread that load across multiple zones rather than having it in just that high availability zone. You get regional persistent disks that gives you durable storage and replication between two zones within the same region. And regional operations. So like we said, operations are per zone, per region, and a global resource. And in this case, if you're performing an operation on a regional resource, such as a regional external IP address, then that's a per region operation. Finally, zonal resources. So zonal resources are hosted in a zone. They are zone specific and are unique and only usable in other resources in the same zone. So per zone resources can be an instance. A VM instance is located within a zone and can access global resources or resources within the same zone. Persistent disks, machine types, instances, and disks can only use a machine type that is in the same zone. So if you're trying to use a machine type that only exists in US East 1 and you're in US East 3, then that's not going to work, right? The instance, the disk, and the machine type must be all available in the same zone. Cloud TPUs. TPUs are zonal resources. Machine types are zonal resources. Like we mentioned earlier, you have to have a machine type, a disk image, and a snapshot, or a disk that's available, all in the same zone. And much like regional managed instance groups, you can use zonal managed instance groups. So if you have a group of instances that are all identical and similar, you can group them together in a zonal managed instance group, and then manage it as one single entity. And finally, latency. So depending on your type of application, you've got a couple of different options to decrease your latency, and that all revolves around load balancing. You want to load balance, especially for a high availability application. So you can perform HTTPS load balancing that supports SSL traffic. It does URL mapping, SSL offload. It can perform proxy load balancing for TCP and SSL for non-HTTP. You also have network load balancing. So this is a TCP UDP load balancer. It is delivered using Google's maglev technology, and it used to distribute traffic to backends with high performance. Alright, so latency as a whole is something that you really want to decrease in the Google Cloud Platform. And that really comes down to using a combination of a proper machine types, proper network configuration, proper load balancing, and latency. And of course, making sure that you're deploying your applications and workloads close to your end users.